Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm here with Chris Anderson, the founder and CEO of Vantem. Vantem makes energy-efficient, climate-resilient, and cost-effective homes at scale. Key to their product is a proprietary panel technology, which is where at least some of the hardware innovation comes in the story. I'm really excited to talk with Chris because I've been wanting to better wrap my head around how home construction and climate change are interlinked. In the US, at least, 20% of our greenhouse gas emissions are from home energy use. There's also the emissions associated with the materials and construction of new homes. And then homes can also be an important tool in improving our resilience to climate change. It looks to me like Vantem has a take on all of these things and probably more. I'm just meeting Chris, but I'll share a couple of highlights from his background quickly. Since founding Vantem, he has led the company to build over 3 million square feet of structures. Prior to Vantem, he co-founded and headed a business that was a pioneer in the use of sustainably harvested timber, and he grew that company to 1,600 employees operating in 6 countries. So he's clearly a guy who gets things done, and I can't imagine there are many people in the world better equipped to shed some light on the interplay between home construction and climate change. So Chris, I'm really honored to have you on the show. Thanks a lot for joining.
Yeah, well, Dylan, thank you so much for your interest. Looking forward to it.
So I read that you grew up in both South America and the United States. Where in South America? And is that where your family's from originally, or what's the story behind that?
Well, my parents, they're American, but they decided to join the Peace Corps. They were in the second group of the Peace Corps ever created under President Kennedy. And they moved to Bolivia. This is in the early 60s. And now in their 80s, they still live there. So I grew up in Bolivia, kind of my early life, later came to the States to college and all that good stuff. And my whole life has been bridging different cultures, bridging different challenges, and looking at it more from a global perspective, really born in that early stage of the family. Yeah.
And would you say that your life in Bolivia has been an influence specifically on your focus on housing? It looks like even before Vantem, you were in this space of sustainable materials for construction and things like that. Does that come from influences in Bolivia?
Yeah, for sure. And I think more broadly, my interest in sustainability overall comes from there. So actually, I grew up more specifically in the Amazon rainforest when I was really small, and so until I was 8 or 9 years old, I lived in the Bolivian Amazon. And even then, you could start to see the impacts that humans were having on this just incredible habitat. And part of it was deforestation for things like food production. Part of it was also deforestation because people were looking for a place to live, right? So kind of the first business I built was focused on trying to give the forest a value by sustainably harvesting timber, giving that forest a value that would exceed the value of it as a grassland, right? Which was basically one of the main sources of deforestation at that point in time. And after we sold that company and had developed a more profound understanding of how housing and the built environment was starting to impact things, that was the genesis of Vantem and the idea that we needed to develop a better way of doing things in that realm.
Interesting. Okay, so without the company focused on sustainable timber, it was more valuable to deforest and use the land for crops or housing or something like that. So you got it. That makes a lot of sense.
Exactly.
Yeah.
That was exactly what was happening. Still, unfortunately, today it happens. If that forest doesn't have an economic value, just the way our world works, it's very difficult to preserve it, right? So kind of the thesis of giving it a value by extracting selectively in a way that lets it regenerate naturally, I still believe is probably the best way to preserve these important natural assets. And yeah, it was the place where we started to focus in on how can you bring a lot of the lessons we learned as a kind of a world-class manufacturer, because we were doing sustainably harvested timbers, turning them into windows and doors. We had very sophisticated equipment, really, a lot of computerized stuff. And we were making windows and doors a thousandth of an inch and a tolerance. And then you go to construction sites where the stuff was being installed and they're putting the window in a hole that was 5 inches off, So it became clear, hey, kind of the dual challenge. People need housing, but we would love for the housing to be less impactful on the environment. Hopefully not impactful at all, but hopefully at least less impactful. But you also needed to do it in a way that was affordable. And clearly the way that homes were being built all over the world, part of the challenge was the productivity was low because they were just employing systems that are 100, 200 years old, very different to the technology we were employing to make the windows and doors these homes were going into, right? So that was part of the spark. And again, the reason why we decided to focus and refocus on trying to address the issue more broadly in home construction.
Got it. So it's the first company was kind of materials for the home and components of the home, and Vantem is an evolution of that, looking at revolutionizing the way the entire home is built.
Precisely. Exactly. This goes back when we started looking for solutions to address the issue as you framed it. This is 15 years ago. And at that point, it was already quite clear that climate change and the built environment was contributing towards climate change and CO2 emissions quite dramatically, right? So the goal that we set out for ourselves from the very beginning was, okay, first of all, we do want to build in a less impactful way, meaning a more energy efficient way, a way that creates less waste and is overall less impactful. And then secondly, it had to be affordable. I mean, human beings do need housing, and I do believe there's a right to an affordable house, which is hard to achieve. And so we looked at both of those challenges together. The productivity side of it was, I think we were pretty uniquely situated because we'd spent so many years thinking about how do you produce windows and doors better, and it involves automation and simplification. And that's a bunch of the learning that we brought to bear to this idea. So how can we factory build homes, in so doing, make things more efficient? And as we addressed that challenge, the one thing that became really clear was that the traditional systems being implemented to build the actual homes are complex. I mean, they're old, they're outdated, but they're also complex, right? So overseas, people build with brick and cement mostly. And so you have a lot of parts, a lot of layers, a lot of complexity. You got to put steel inside and all that. Well, in the US, we build mostly with timber, right? And it's the same problem. A lot of parts, a lot of layers, a lot of complexity. And so improving costs on that becomes really difficult, right? Because the productivity is really low at the end of the day. And so the thought was, if we could address the productivity side while creating a system that was energy efficient, we'd check the two biggest boxes that we felt and still believe are the most important ones when you're addressing affordable housing and energy efficiency.
Okay. So Vantem is checking these two big boxes of improving the operations of building a home and the efficiency of a home when it's being lived in and during its use.
Right. And making sure that in doing so, you can do it in a way that can be applied, that's scalable, that is going to be scalable internationally and address the issue on in a big way. So that's how we landed on kind of the idea of using a panel rather than other ways of solving for this problem. We traveled the world. We put together a really great team. Many members of that team still are with us today in the company. But looking at what other people were doing in the world, and there are a lot of different solutions. Most of them are partial. They might be great with energy efficiency, but they're expensive, or they might be applicable in a place like the United States, but the rest of the world, it might really not work. And when we were traveling the world, the one system we kept coming back to that we felt checked most of the other boxes that we wanted to check were panels. And so structural insulated panels have been used in the US in particular for 70, 80 years. But those panels have typically been made with wood-based products, right? So they used to be made with plywood on both sides and an insulation core, then later with OSB or in a strand board on both sides. And it's a great product. It simplifies the construction process, right? One panel replaces a bunch of parts, and it is a more effective insulation. The problem is that because it has the wood layers on both sides, it's not as simple as it could be, right? You still have to put drywall on the inside before you can paint it. On the outside, you have to protect it with siding and different things. And internationally, wood is actually in many places not considered a real material to build with. So you can't even get it through code, right? For code approval. So
because of climate issues, like it's too resilient to moisture and that kind of thing, or?
Yeah, I think there are a lot of prejudices about how that works, termites and moisture and so forth and fire. But at the end of the day, it's just a historical kind of experience. Most other places are just used to brick and then cement as the main materials, right? So, and to that effect, we focused on how do you replace that board, that plywood or that OSB with something that would still allow you to build a structural panel, but resolve the other issues. But the other being, again, right, that you don't have that it'd be paint ready and doesn't need more layers on the exterior. And by being structural, it would not need additional steel and wood and things like that in there. And it would look and feel like a structure that people are used to all over the world. Once it's built, it's not going to look funky and weird. And that's what we focused on and did develop. That's really at the core of our intellectual property is this special board. It's kind of a ceramic-like material that we developed that meets all those requirements. So when we now build a panel, it's simple. We can build the entire home with that panel without a ton of reinforcement, things like that. And it greatly simplifies everything, which in the end reduces costs. And the panel, because it has an insulation layer all down the middle, uninterrupted by, say, 2x4s like you would typically have in a wood frame home, you have a continuous insulation layer, making it a much, much more effective thermal insulation in terms of the thermal envelope of the home when we build it.
So the outside of the panel is the envelope, is the outer layer of the home, and the inside of the panel is your paintable surface inside the home.
Exactly.
It's the full wall all in one, one assembly.
Right. Mm-hmm. Right. And these are 4 feet wide. So, and however tall if it's a 10-foot ceiling, we have a 10-foot wall panel. That one piece, that one panel will replace 50, 60 parts that you would otherwise have in that same area when you're building it with traditional methods.
Detailed question, but what about things like running plumbing and wiring and things through the wall, which we usually do in that cavity between studs?
You still can. We run electrical through those walls easily. I mean, you're talking about walls that are 4 or 6 inches thick, and we run a 1-inch diameter wire chase right down the middle of that panel. So it doesn't affect the structure, and it's actually quite easy to do. And then the other part is when you look at heavy plumbing or heavy MEP, we try to design the home where those run on the interior walls that are not load bearing, and it makes it just easier for the whole process that way.
And then from a process standpoint, are these panels built and assembled into full homes in a factory setting, or are you shipping things to be assembled on site?
Yeah, great question. So we started life out building homes on site by shipping the panels there. Okay. And then, but with always the idea that we would be doing as much in a factory setting to make the whole process the most productive possible. And we migrated to that about 5-6 years ago. We started doing our first modular structures fully in a factory. And since then have moved our entire production system to that model. So currently we deploy that panel inside a factory that is building homes like on an automotive production line, right? We build the entire home inside that plant, deliver it complete with the electrical, the plumbing, the kitchens, the bathrooms. It's 80% of what you would typically do on site. We're doing off-site in this factory setting, right? And what's really cool is that the same efficiencies that you can imagine that our panel brings to site building, it brings to the factory, which is hugely important because it makes the whole factory more productive. And another magical thing happens. We don't need to invest as much money on automation and on expensive equipment to build the same number of homes, right? So when you compare a Vantem factory to other modular factories that are trying to address the similar problem, what you would find is the Vantem factory is simpler. And we have an investment that is a fraction of the investment that it typically takes when people are trying to build modules with wood, for example, and automate with robotics, the wood systems, right? Because you're essentially trying to automate a complex system. That's hard. That usually is expensive. In our case, we're automating a simple system. That by definition is easier and less expensive. So that's another aspect that makes our system more scalable. We're able to put factories in for less money, or less investment, and it makes it easier to put more factories in all over the world.
Right. You're assembling panels. You're not framing a whole house with 2x4s and plywood and putting drywall on and all of that.
Right, exactly. I mean, you can imagine, and for those that have been through some of these factories that are automating wood construction, It's amazing the amount of automation and robotics and complexity that they have to undertake. So we simplify all that.
And how would you characterize the problem you're solving? What do you think the biggest impact of your approach is? Is it, I talked about from a climate change perspective, there's the greenhouse gas emissions of the kind of material supply chain and the construction process itself, then the use of the home over time. And then you could also think about kind of climate resilience. Like, what is the kind of main motivation or main benefit of what you're doing? How would you characterize that?
Yeah, I mean, so while our homes have a lower embodied carbon, right, in the construction process, our panels are fairly low in embodied carbon, the real impact is energy efficiency over time. So you can think that an average home might have 40, 50 tons of embodied carbon, depending how you make it. We have less than that. But that same home, when you compare Vantem to traditional construction with wood framing in the United States, for example, we have 70% more energy efficiency. So there's 70% less energy that is lost. And we did an exercise recently of comparing a Vantem home in Birmingham, Alabama to a wood framed home in Birmingham, Alabama. 2,000 square foot home, kind of an average sized home. When you translate the energy savings of Vantem over that traditional, over 50 years of kind of a short lifespan, let's say, that's 2,000 tons of CO2 reduction. It really is the energy efficiency that has the huge impact on the climate change side. And we're very fortunate at Breakthrough Energy, which is kind of a leading fund that was created by Bill Gates, right, to really address climate change and invest in the space to try to support solutions that are very, very meaningful on carbon reduction. They came on board as an investor and very involved in the company about a year ago. And the reason they did it is because that they understand that the built space, as you mentioned in the introduction, is a huge part of global emissions. And Breakthrough compared, they tell us 500 different companies and technologies doing the kind of things that are trying to do what we do, and decided to invest in us because we kind of check all those important boxes. We're able to truly reduce carbon emissions. We've proven it in difficult places, South America and internationally. And we're able to do this on a global scale, which is, the kind of solution that you need if you're going to have a meaningful impact in the space.
Yeah, I should have mentioned that in my intro. The investment from Breakthrough Energy Ventures is what really caught my eye about Vantem. It tells me you must be doing something that's having an impact on climate change in a meaningful way. So that's really cool.
Yeah, no, Breakthrough's been just a great partner, obviously, as a great validation of what we've been doing. I mean, they did some incredible diligence when they were considering the investment, and I think verified kind of what we say we do. And since then, Breakthrough has invested in some of the most leading companies in this space, and one becomes kind of part of a family of solutions that starts to create some cross-pollination. And we're just really fortunate to have that support.
And that 70% reduction in energy use, is that primarily about the higher insulation value, higher R value, essentially, of the walls? Or where does that come from?
Yeah, so there are two aspects that make, say, traditional wood frame construction not as efficient as Vantem. The first is there's more air leakage. So there's more energy loss through leakage. It's hard to make an airtight envelope when you're site building something that has so many parts and so many breaks and all that kind of stuff. So on average, you have a 25 to 30% of the energy loss in a home is through that leakage, right? Now, the other part is just that inherent issue that you're building with 2x4s every couple feet at least, right? And what that is doing is it's breaking the thermal envelope, right? So because you only have insulation in between those 2x4s or the wood studs. So what that means is that, yes, you are putting, say, R19 fiberglass in the wall, right? But the true insulation of that whole wall is probably closer to R12 or R13. Because those 2x4s are breaking the insulation and end up being thermal bridges. Vantem doesn't have any of that. Our homes are more like beer coolers. There's nothing interrupting that thermal insulation layer. So when we build an R19, and we build higher than that, but just in the same example, if it's R19, the whole wall is an R19 wall. It doesn't have that interruption. So that is really, at the end of the day, what makes it so much more energy efficient.
Yeah, I can say from personal experience, I've noticed that. So I did a remodel on my house and kind of geeked out on trying to make the envelope as tight as possible and improving the insulation. And We did a blower door test. So this is where you kind of close all your windows, put a big fan in one of your doors, and try to suck a bunch of air out. And you could just walk around and feel all the leaks in my house. It was kind of terrifying. So I went around with like a can of foam and tried to plug them all out. And this was basically new construction. It was a remodel, but there's no reason why there should be.
And it wasn't easy, was it? I mean, that's a tough thing to do.
It wasn't easy. No, it's a tough thing to do. And I would guess most people don't even bother. And yeah, even with all my effort, I still have leaks all over my envelope. And then I grabbed a thermal camera from our lab here at Synapse and looked at my house from the outside, and you can see all the framing. Just like you said, each 2x4 is a cold spot in the wall. So anyway, just to say I've seen both of those factors from personal experience.
You can sympathize. Well, and imagine, I mean, the other part that we're focusing on is cost, right? We're focusing on building not just highly energy efficient envelopes, but affordable envelopes, affordable housing. And kind of the problems that you encountered are magnified greatly when most builders are trying to build an affordable house, right? They're moving fast. They're having to, kind of go as fast as possible and just can't afford to put in the time and a lot of times all the materials that it takes to make that envelope airtight. So unfortunately, as you move more into the affordable housing space, those problems get worse and worse, usually in the affordable housing space. Yeah.
Let's talk about that a little bit. I mean, I don't know how directly linked it is to climate change or not, but I know that we have a housing shortage, an affordable housing shortage. I mean, we hear about it all the time in California and US in general. How could you help me understand what's driving that and why affordable housing is so important?
Right. So there are a lot of things driving that, right? There are things that are harder to address that require political will that revolve around zoning issues and things like that. That is an important part. But probably the biggest drivers of cost are that when you're still building like we were building 200 years ago, when labor and materials were a lot less expensive. Well, we all know inflation has the impact of inflation on materials and certainly on labor. And so when you're building traditionally, you have a lot of labor in a home, a lot of labor hours. And unfortunately, a lot of those hours are not spent productively, right? That expensive labor is having to move from job site to job site. There's a lot of dead time, and all of those things add up to costs. And then you have systems because of their complexity that are quite wasteful. There's a lot of waste built in. So that's on the construction side. And so what we believe in firmly is that one of the important parts of reducing those costs is to be able to build offsite, built in a factory, so that you can resolve that lack of productivity and make the labor more productive. So in a factory, what's happening is the house is moving to the person, right, on the assembly line. And that person, that skilled tradesman, is able to produce a lot more during their same 8 hours of work than if they were having to move around in their pickup truck from job site to job site and things like that, which is what is typically done in traditional construction. And then I go back to kind of the simplification of the system. If you have something that has a lot of parts and a lot of layers, by definition, there's just a lot of cost in there. I mean, and if you're able to reduce the parts and reduce the labor, you're able to reduce the amount of materials and reduce the cost. So back to your question, why has affordable housing been so hard to attain? It's because the cost of doing things the way we have for so long has gone up and is no longer in sync with incomes, right? And so suddenly the cost of homes has gone up much more rapidly than income has gone up for most people.
Right. So a big part of the problem is if we could build homes more cost effectively, we could have more homes for everybody. And can you characterize how big the housing shortage is? Like, how big is the mismatch between population and housing available?
Yeah, the number's a little bit fuzzy, but kind of the number that is most often cited is that there's at least a shortage of 4 million houses or housing units in the United States alone, but from an affordable housing perspective. Then you have a lot of other things, which are that you have perhaps people that are renting currently that could, in fact, probably prefer, in fact, to be owning a home. They're not really counted in that housing shortage, but they're renting because there isn't something that they can afford, right? But it's at least 4 million units. It's a big, big deficit. And it's a deficit that in part was created when the housing downturn occurred in 2008. This isn't the only reason, but it really ballooned during that time because there was almost no housing built during that time, right? but more housing demand with demographic changes and with population growth continued. And so that's actually one of the problems we have when we are trying to address the affordable housing side is that it's not only we have to create enough units for this demographic change and demographic growth, but we have to actually try to eat into the deficit that was created 10, 15 years ago. So it's a big challenge.
Mm-hmm. And is it worth touching quickly on climate resilience? I mostly ask because I've seen this great picture, before and after picture of a Vantem home before and after a hurricane. And, after the hurricane, the trees and the plants are all destroyed, kind of, and the home's just sitting there happy as can be. Is there anything you want to share about that and how important that is?
Yeah, absolutely. I mean, so again, back to the goals of having a system that would be globally applicable, right? And that could be applied anywhere. Well, that includes a lot of places in the world that have hurricane or typhoon challenges or earthquake challenges, right? So we set out from the very beginning to make sure that the system was going to be able to withstand those type of impacts. And we've done it. We've proven it by building with this panel. One of the things that's interesting is that we'll get a little wonky here. You don't have point loads. So in a traditional structure, the loads of the structure are coming down through columns usually, or the 2x4s. In our case, every square inch of our panel is absorbing load, right? And so when you build the whole envelope with the panel, all of the loads are distributed to every square inch of the entire wall, exterior walls, and some of the interior walls. So it makes it just by definition a lot more resistant to higher loads. And those loads can be wind loads. So of course, a hurricane is a high wind load. And yeah, to your point, we built homes in Freeport, Bahamas, and the eye of Hurricane Dorian, the strongest hurricane on record so far, went right over where we built. And our home was the only home in the neighborhood that wasn't blown away or severely damaged. And the other aspect to it that's interesting is that it was under 3 feet of storm surge. So the water went up 3 feet during the storm. And when the water receded, aside from having to replace their furniture, the family that owns and lives in the home moved back in because, again, this material, that our panel, it has no organic material in it that is susceptible to mold or to rot. So it's very resilient, not only in terms of the wind loads, but also high humidity conditions. And we've had homes in Chile that have been through 8.2 magnitude earthquakes. Same thing, an earthquake puts all kinds of weird loads on a structure. And by distributing the loads across all the walls, we do very, very well in those type of conditions.
Very cool. What's the business model? Are you selling homes directly to consumers, or how does that work?
Yeah, no, great question. So what we do is really partner with large developers that are looking to produce affordable housing around the world. But right now, we're very, very focused on the US. We started our rollout overseas, but turned our attention here to the United States. And we have a goal of building 20 factories here in the US across the country over the next 10 years. And the way we do that is, again, by partnering with developers that have kind of that pipeline. They have the land, the vision, and the ability to deliver homes where they're needed. And we put a factory in a place that can service that need. So we began our rollout in the southeastern part of the United States. The first step of that rollout actually is we bought an existing factory in Georgia, Affinity, a great modular manufacturer that has really made a great name building highly hurricane resistant homes using wood systems in the modular factory. So we bought Affinity a few months ago, and we are in the process of converting that factory into a Vantem production system. So we'll be retaining all of the great aspects that Affinity has always delivered to the market of a high quality home, highly resistant to wind, but we'll be adding high energy efficiency and net zero options along with that. And so our goal is to potentially acquire more factories that might be available to convert to Vantem, as well as build greenfield, build new factories in the areas that perhaps there isn't factory for us to be able to acquire, but where there's a demand and a need.
Mm-hmm. You want to have factories close to where the homes are eventually going to live.
Yeah, I mean, you're building modular structures that are 16 feet wide and 72 feet long often. And so, yeah, although you can travel quite far, you can go 300 miles, 400 miles from a factory and still be quite competitive. The closer you are to the factory, the better. So, yeah. And since the output of an average Vantem factory is somewhere around 500 to 1,000 homes per year, depending on the home size. To make a significant impact on on the affordable housing deficit, it's going to take a number of factories. So we're looking to strategically place them across the country. Yeah.
And what's driving the kind of uptake by these big developers? Is it mostly they can build more housing units cheaper with the Vantem technology, or is there any kind of sustainability motivation? Are people picking these up because of the energy efficiency?
Yeah, so I think there's several things that we help solve for, and then several things that we bring that are completely new to the equation, right? So some of the basic things that we help developers solve for are we are taking away the biggest risk they have as developers. The biggest risks that developers have are site, on labor, weather, and all these kind of things. So by producing the home in the factory, you're resolving the biggest risk point that most developers have. Now, part of the reason developers haven't migrated more to offsite construction is that often high quality offsite construction is more expensive than on-site. Well, with Vantem, that's not the case. There's no green premium with Vantem and no premium in cost with the way we build. So we're able to deliver a less risky product for the developer at a cost that is usually lower than what their costs would be to site build, right? And then you add on top of that we're able to deliver that same house with attributes that they've never been able to deliver to the market, which would be high energy efficiency, including net zero options where we're putting the solar panels on the roofs and being able to deliver net zero, even in some cases net positive. So this allows the developer to deliver a much better product into the marketplace at an affordable cost. And now, some of the other things that are interesting that happen is that are more kind of in the financial realm, right? So one of the things is that by building in a factory, you can build in a lot less time. And so we're able to reduce the build time by about at least half. So developers measure return on investment, ROI, and the formula time is an important part of that. If you reduce the production time, the installation time by half, you double the return on investment, the ROI, right? So wow, it's just magic. They love it. And then the other thing that is interesting is that energy efficiency is bringing to the table new financial instruments that lower their costs, and they lower the cost for everybody, all the way down to the homeowner. So we're working very strongly with important banks and important sources of financing to provide lower rates on the loans to businesses, to our developer partners, because they're building a green product, a high ESG, a green product. And the other thing that it also allows is banks to start to think about how they can offer more attractive mortgages to the eventual homeowner. So there's kind of a full suite of different benefits that the factory building and the high energy efficiency bring to everybody in the chain, from the homeowner and the developer on out.
Wow. Very cool. Yeah, the timing thing really sticks out to me. Even just to reduce the risk of market volatility, to reduce the amount of time between when you commit to the investment and when you can realize the return must be a huge benefit.
Yeah, absolutely.
Yeah, cool. So on the panel itself, I'm curious, it sounds like you have some IP around it. That's been a really core part of what makes your product different. What was the innovation process like to develop that?
Yeah, so like I said earlier, the key was to replace the structural board, that plywood or OSB that was used to make structural insulated panels. And it's not an easy thing to do, because you need for that board, to be structural, be able to carry loads, but you also need it to be able to do things like hold screws effectively and all kinds of things. So it really was a tall order. We put together a material sciences team that was kind of international. We had folks from Asia, from the US, from South America involved in different expertise. We ended up developing a product that borrowed from a lot of different disciplines, right? So it's a board that it borrows on refractory sciences. So, materials that are used in high temperature ovens, because you need this to be a fire rated product. So our board is a refractory material. It borrows on knowledge that comes from the ceramics world. It borrows on knowledge that comes from the cement world. Although we don't have any Portland cement, there's a lot of knowledge that we brought in from fiber cement production technology. Again, we're not using Portland, but we are borrowing kind of how some fiber cement is made and replacing a lot of things we don't like in fiber cement. And so it was a long process. It took us about 5 years to develop a solution to the point where we were comfortable that it could be deployed. And since then, we've made 2 improvements to that formula. And we have a team currently today that continues to work on ways that we can improve even further. But to put in context the challenge, the way a structural insulated panel works is a lot like an I-beam, right? So why is it so structural? Well, because each of the faces on both sides work like the exterior flanges of an I-beam. And the insulation layer we have is like the central flange. The skins have to work in compression and in tension. So both stretching and compressing, because that's how it works. It's like standing an I-beam up. Microseconds, each side is going to be in compression and tension. And so you need to be able to have a board that checks all those boxes. And in so doing, still not be susceptible to weather and all the other things that I described before. So it was quite a process, and we really had a lot of talented people working on it.
And we're talking about the material innovation is for the kind of bread on the sandwich, the outer and inner layers surrounding the insulation layer.
Exactly. That's the key. And we adhere that to a structural insulation layer in the middle, but it's really those exterior boards, the bread in the sandwich, as you say, that gives the whole panel the structural values. It's obviously the part that protects the house, because that exterior slice is what is in contact with the elements, and the interior one is what you feel on a day-to-day basis, because it's the inside part of your interior walls and where you might hang your big screen TV and all those good things.
Yeah, so that I was just going to ask that's the critical question. When I'm hanging my TV or a towel bar or whatever, I don't have to look for studs anymore.
No, it's awesome. You don't. You just drill wherever you want and hang that up. Yeah, the screws go right in, and you can hang the largest TV you can buy. It's not a problem.
I mean, forget climate change. That's reason enough right there.
Yes, sir.
I would love to throw away my stud finder. That never works. Very cool. So you've talked a little bit about this, but just thinking about the future of Vantem, it sounds like your big focus now is expanding to the US. What does the future of Vantem look like? And I don't know if the way to characterize it is relative to that 4 million housing units shortage we have today. Like, do you think Vantem will take a big bite out of that? What kind of scale do you envision? Where's the future of the company?
Yeah, so we are focused on the US rollout right now. We will be coming back to our international rollout after we've taken a few more important steps here in the US. And again, our goal is to build at least 2 factories per year, each one with a capacity to do 500 to 1,000 homes a piece. And so, whereas that feels really meaningful, and I think it is, unfortunately, it's still just scratching the surface on those 4 million units that we're talking about. But that's where we're focused. And then we'll be turning our attention internationally to continue a rollout at about the same pace of 2 factories a year elsewhere. We're looking to make our impact the most we can, but it is a huge lift. We're going to need a lot more people focused on the same thing before we can put a real dent in the affordable housing issue.
Do you foresee that the kind of housing construction industry will change over time? Stick frame buildings have been the standard, at least in the US, as you described, for so long. Do you think the work that you're doing and maybe other companies like you is going to start to really change the industry altogether? Like, will stick frame buildings be a thing of the past at some point?
I suspect that what's going to happen is going to be similar to what we saw in the car industry and EV, right? It took a long time, and there were small inroads made along the way. That's kind of where we are right now in new construction technologies. But everything points to the need for a wholesale change in the system if we're going to be building more affordable, and especially if we're going to be building more energy efficient homes. It's not possible to do that with the systems today. It just doesn't work. And so, particularly as we're looking to address climate change, it's inevitable that the whole system needs to be rethought, and important changes need to be made, and new technologies come in. And those, I think, are now becoming more competitive versus the traditional, which is part of the issue. And that's one of the things we're really proud of, is we don't present a premium to the market, right? I mean, premium solutions don't really take off. But now, as we present our solution, and hopefully others present solutions that are competitive not only on the energy efficiency side, but they also are competitive on the cost, the homeowners that are buying homes are going to start demanding them, just like people are demanding electric vehicles now. And that's really what, at the end of the day, is driving some of that change in that market. So I think it's going to be following something similar.
That reminds me of a question I meant to ask earlier. What can you quantify the cost savings? Is it a typical single family home cost to build delta is X dollars?
Yeah, typically we're 20% less expensive than traditional construction. Now that delta is higher in expensive places like California for the most part. And the delta might be a little bit less in a place like rural North Carolina, but we are on average about 20% less expensive to build.
Yeah, wow, that's a big chunk. Cool. So I have 3 last questions for you. How optimistic or pessimistic are you about the future of the planet and why?
Well, I think the planet's going to be just fine. I think it's humanity that needs to figure out how we're going to do.
Fair.
I think there the glass is half empty, half full. I think there's a lot to be optimistic about. I think there's a lot to be seriously concerned about. And we're really at that tipping point, right? So I think the technologies are starting to kick in that will make it possible to really, truly solve this problem. We need to generate the political will to make it happen.
Who is another company or individual doing something to address climate change that's inspiring you?
I've always drawn a lot of inspiration, and this is kind of one of the Paul Hawken, who wrote a book a while back, The Ecology of Commerce. I draw a lot of inspiration from it because he really early on distilled the challenge and the opportunity of turning capitalism to the benefit of climate and ecology, rather than have it be a detriment. And he continues to do some really important work. So he was early, he was eloquent, and I think identified the problem in a way that many of us really identified with, and has been just a huge influence on how I've looked at the challenges.
Cool. I need a new book. I'll check it out. What advice do you have for someone not working in climate today who wants to do something to help?
Yeah, so everybody, and I don't think I'm saying anything new when I say, but we all make little decisions every day. And those little decisions add up. What do you buy? Where do you buy it? Do you buy? Do you add to the kind of the demand that sometimes adds to additional production and CO2 and all this kind of stuff? That's the everyday. And then at the top, this is a huge challenge. This is a challenge that, again, without political will is going to be very, very difficult to tackle. And so I think everybody really needs to hold their political representatives accountable to do what they believe is right. And it's going to take all of that.
Well, Chris, that was really fun, and I'm really impressed by what you've already accomplished and excited to see the expansion of Vantem in the US. Thanks so much for your time. I appreciate it.
Well, thank you, Dylan. I appreciate the interest and really look forward to keeping you posted as we make progress on our mission.
All right. Yeah, I'd love it. Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.